Welcome to Ask and Learn.
All right, so this question said an impurity in water has an extinction coefficient of 3.45 times 10 raised to the power 3 per molar per centimeter at 280 nanometers. So its absorption maximum, that's the absorption maximum. So below 50 parts per billion, the impurity is not a problem for human health. Given that most spectrometers cannot detect absorbance less than 0.0001, so 0.0001 is the limit of detection for most spectrometer. So it's measuring the absorbance of a water sample at 280 nanometer, a good way to detect concentration of impurity above 50 ppb threshold. So the equation that connects absorbance to extinction coefficient and concentration is A is equals to ECl, where A is absorbance, and this is the extinction coefficient, and C is concentration, and L is the path length of cuvette. Okay, cuvette is just the sample container. So we know the extinction coefficient to be 3.4 times 10 raised to the power 3. Okay, and the limit of detection of the spectrometer is 0.001. So what we can do is to calculate concentration. So concentration will be A over C over EL, and the absorbance is 0.0001. So this will give us a concentration that the spectrometer can detect, and the limit and the extinction coefficient is 3.45 times 10 raised to the power minus 3 per molar per centimeter, and the path length we can assume to be 1 centimeter. So therefore, C would then be equals to 2.895 times 10 raised to the power minus 8 grams per liter. So we just need to convert the 50 ppb to grams per liter, or we can convert the this concentration to parts per billion as well. So if we look at it, 50 ppb is equivalent to 50 microgram per milliliter, and this is equivalent to 2.895 times 10 raised to the power minus 8 milligram per milliliter. So the question said that is measuring the absorbance of water sample at 280 nanometer a good way to detect concentration of impurity above 50 parts per billion. So 50 parts per billion is 50 microgram per liter, and the limit of detection for the spectrometer is 2.895 times 10 raised to the power 8 milligram per liter. So we can as well go ahead and convert these to microgram just to have a good basis for the comparison. So milligram to microgram. So if you have 2.895 exponential minus 8, so this will be 2.895 times 10 raised to the power minus 5 microgram per milliliter. So the spectrometer can measure as small as 2.895 times 10 raised to the power minus 5 microgram per liter. And we are asked that can we use the spectrometer to measure things greater than 50 microgram per milliliter? Yes, because the lowest amount that the spectrometer can measure is 2.895 times 10 to the power minus 5 microgram per milliliter. And if we have 50 microgram per milliliter, then the spectrometer can measure that.